Hello everybody, my name is Bruce and we're going to give a little class today on networking and internetworking, and basically it's going to be about how computers talk to each other. And that includes both in a local area, could be just in this room here or in this building, or it could be the entire world over the internet. So we're going to cover all of that in 2 hours. So hold on. Press the start button there for the countdown timer.
Go on.
And I'm all pinned over here, so we're ready to go. Okay, so I titled this, How Do I Internet? Because, and notice I spelled internet with a capital I. When you see internet spelled with a capital I, what does that tell you? That's the big internet. That's the World Wide Web. That's the one that's out there that you get to when you go www dot and you go to a website. That usually is the internet. Now that doesn't mean you can't have websites within your organization that you don't have to go out to the internet for, but they don't get prefaced by www, because what does www stand for? World Wide Web. Right. So anyway, what we're covering today can be really dry or it can be fun. We're going to try to make it fun. And I'd like you to ask questions along the way if you have any questions, because that will make it probably more interesting for the group as a whole, because we're all coming from a different place, different amount of experience, things like that. So hopefully we can learn from each other. Okay, so I'm going to click on this first link here. I had this great link that I had set up right here, How Do I Internet? And then my computer just got the new 1903 update. It started blue screening on me all the time. So it would just shut down, and anyway, I lost that link, and one day if I find it, I'll share it with the club again. But it had pretty much everything I'm covering in this evening's session under just that one link. So maybe it's just my way of being told that, no, Bruce, you need to go through the whole thing. So we're gonna go through it, and we're gonna have a little fun along the way. So this little link over here is this one down here. It's called the OSI Model Explained, How to Understand the 7-Layer Network Model. It's a tutorial on the Open Systems Interconnection Networking Reference Model and tips and how to memorize the 7 layers. So first of all, we don't need to memorize the 7 layers, not even one of them, okay? We're just doing a preview here. But if you were to click on these links, you would see that there is instructions on what those layers are and what they do, okay? Number 1, you'd think it would be on the top, but of course they put it on the bottom. Okay, I'm just going to go ahead and talk a little bit about these in the beginning, and then we'll go over them a little bit more as we go through. So when you see physical here, you need to think of, well, we got a wire here, we got a computer here. That's physical stuff. Those are things you can touch. Okay? So when you think physical layer, think of everything you can touch. Your wires, your computers, your routers, different things like that. That's all part of the physical layer. It also includes your connection to your internet service provider, which would be abbreviated as ISP, Internet Service Provider. Anytime you have a 3-letter acronym, we call that a TLA. 3-letter acronym, T3L letter A acronym. What do you think you'd call a 4-letter acronym? FLA. Yeah, so you may hear me slip into the TLAs and FLAs, and once you get that, you can say, well, I'm not a beginner anymore, I'm an advanced beginner. Okay? So we'll move forward on that. But anyway, so the physical stuff you can touch. Now, when we start getting into I don't know why my mouse cursor is blinking, but we'll deal with that. When we start getting into the rest of it, we're dealing with more abstract things you can't touch. Okay, so those things would be more logical than physical. So the difference is logical are things they're represented by something. Okay, so you can't touch the data link layer. But the data link layer is how the information gets from the wire to actually start talking to your machine. The network layer is when protocols start getting applied that allow you to communicate between devices. The transport layer is basically how systems talk to each other and actually communicate back and forth and do things like handshakes and things like that. Session layers, how do we open a session? It's like when you make a phone call and someone says, hello, okay? So saying hello is creating a session where you can actually talk to each other. The presentation is how do things get presented to the actual networking information. An application is the applications that you are actually using to, like your web browser and things like that, the applications that you're using to be able to use these different rules that we have. And we don't say rules in computerdom, we say protocols, okay? Protocols are different rules and different entities that are agreed upon in something called RFCs, or requests for comments, by people out there who know a lot of stuff, and they talk about stuff and they fight back and forth, but they come up with all these rules, and those are the way that we represent things to each other and to other people who live in the networking world. For the rest of us, it's mostly, yeah, it works, no, it doesn't work. It's more binary. But we're going to take a look at some of these different things here, and we're going to work through some of them. Okay, let's go ahead and take a look at a list of protocols that you'll need to memorize by the time this evening's over. And here they are right here. So how you doing so far, memorizing them all? Pretty good, huh? Bottom line is there's just a whole bunch of them, okay? And we're not even going to bother trying to memorize any of them. Some of you already know. For example, if we look at the application side here, we see something called HTTP. Now we're all familiar with HTTP because that's our basic protocol of the internet, right? That's how we go out and we talk to other websites and things like that using the HTTP protocol. Now if you'll notice, this has 7 layers here, okay? So when networking was first introduced at every level, this is called the OSI model, and the OSI is an acronym, and we'll come across what it means in a couple minutes. But it has 7 layers, and you notice that this guy here doesn't have 7 layers. Well, what happened? This is the one that we're using now. Okay, and this is, once again, it's kind of a theoretical model, logical model, that's constantly changing, but it's changing fairly slowly. But what's happening here, this is the original model that I had to learn to memorize and things like that. But this is the model here that is used on the internet, and this is the model that we use internally now in networks. But when I first started out with this stuff back in the 1980s, this was the model that we were working with, and they were only using this at the university level and the defense level. Now everybody's using this model here. It's still called the OSI model, but it's optimized for TCP IP networks. Now, what the heck is TCP IP? In fact, what the heck is networking? Why don't we start with that? So what is networking? What's the difference between networking and a standalone computer?
Connected with other device.
Exactly. It's connected to other devices, usually other computers. So when we talk about networking, it means we're sharing information between computers or other devices in a small room like this one here. We could have multiple computers, and that would be called a local area network because it's local to this room. It could also be this whole building here if it's within the means of this whole one network, and that would still be called a local area network. But when we go out to the internet, when we pay Nicola or CenturyLink or Wave or somebody money to get connected to the internet, we're going out to something called the wide area network, okay? And that's abbreviated with a TLA, WAN, WAN, wide area network. Is everybody with me so far? Okay. Our goal is to cover these things without making it sound difficult. So as soon as I make it sound difficult, raise your hand and I'll take a step back. But so far, I think we're doing okay. All right, so if we look, so I was talking about this model here compared to this model over here, okay? And the way this works is, let's say I'm a computer with a wire here, and I want to, send some information between two computers. The first thing I need to do is I need to get that information and send it over a wire. So I'm going to go to the physical layer, okay? And then I'm going to step up to the data link layer, which is going to take that information and take it from the physical layer and put it onto a logical device, which would be a network card, and the network connection within your computer that would allow it to start communicating with other parts of your computer. The network is the actual physical piece inside your computer itself, and it's also the logical area where data is processed in order to communicate from one device to another. What I'm trying to say here is, let me get rid of this stupid mouse here from blinking, is that every time you want to send, let's say Dick wants to send information over to this side of the room, like to Sherry over here, he'd have to start in his application, and then it would have to go through the presentation layer, to the session layer, to the transport layer, to the network layer, to the data link layer, to the physical layer, cross the wire, and, excuse me while I get my magic wand here, a little magic wand today as a pointer. Then it would go over to this side of the table here, and it would go from the physical layer up to the data link layer, to the network layer, to the transport layer, to the session layer, to the presentation layer, to the application layer, and Sherry would open up her computer, and on the screen she would see what came from Dick over here across all those different layers and back up, went down one side and up the other side, just so she could share with that information. So that's how the OSI model works. With TCP/IP, some of the things are combined. You'll see that we have media. It's not called physical layer here, but we do have the data link layer, the network layer, the transport layer. The transport layer also includes the session layer and the presentation layer, and then you have an application layer on top. So I know that's a bit confusing, especially if you don't know what those are, so we're going to talk about them. I think this pointer is a little bit short. You hold on to that, please, and please don't cast any spells on me while I'm on the other side of the room there. Well, that's not a whole lot longer, is it? Maybe we should pull it out. Now you can wave the wand and say, good, now it's nice and long. Okay, so now we can point. Okay, so anyway, one computer has something on the screen that's an application. It goes down through all these layers until it reaches the wire. It goes to where it's going to go, then it just works its way back up to the application layer where someone can open a browser and see it on their device. Does that make sense? Okay, a lot easier said than done. We have these different acronyms. This one has 4 letters, so that's an FLA, right? And TLA, a 2-letter acronym. That's a whole different one. But anyway, HTTP, HTTPS, what are those used for? When you go to a website, you have to communicate with them using some standardized protocol. Remember, a protocol is a set of rules. HTTP is an excellent way of getting onto the internet and going to websites and bringing up content. But what do we know is the problem with HTTP? It's insecure, okay? Unfortunately, when all of this stuff was invented, whoever did it had rose-colored lenses on and thought that no one was ever going to be a bad person or take advantage of anybody else. Well, boy, were they wrong, okay? So now we have a protocol that takes the place of HTTP that's called HTTPS, okay, which is secure HTTP. You're going to see secure protocol this, secure protocol that, as we keep going through this session and when you're on your computer. Why are you seeing that? Because originally the internet was being used for communications between universities, within military organizations and things like that, where they had different types of security. But now, once you get out on the internet, it's a whole wild west out there, and you really can't or shouldn't trust anybody, you know, more than you know them, or anybody at all. So what are some of these protocols that we're talking about? So I went to my friendly Google page, Internet Protocol Suite. Okay, and here they are. Here are these layers over here. So and most of these things you've probably never even heard of before. Like BGP, who's heard of BGP before? That's Border Gateway Protocol used by routers. Who cares? You don't care. But if you're a network engineer, you do. But DHCP we're going to be talking about, and unfortunately it doesn't come up on our monitor there, does it? Let's go back down here. Where is my list? Excuse me. Oh, here we go. It's on the right side. Okay, I see it over here. DHCP, Dynamic Host Configuration Protocol. This is a really important one. Who has heard of that? Okay, so I'm not going to waste my time by explaining it. Okay, when you turn your computer on, it needs to have an address so it can talk between computers itself and talk to other computers. If your computer is not networked, you don't need to worry about your computer having an address. But if you want it to communicate, it's like if you're at home and you want to receive mail, what do you need to have? You need to have an address. Otherwise, all your mail gets delivered somewhere else, and that doesn't do you a whole lot of good. So Dynamic Host Configuration Protocol, or DHCP, is that protocol that where the server automatically assigns an IP address and other network configuration parameters to each device on a network so they can communicate with other IP networks. Okay, let's go back to here again. when we're talking about networks, we're talking about different layers of the OSI model here. Excuse me one moment. See my PDF. You'll notice we have HTTP here, TCP here, IP here, and data link layer. Remember we said that we had to have a wire for stuff to transfer over. Well, this example, Ethernet. This is an Ethernet wire right here. This yellow wire, it could be orange, it could be blue. Doesn't matter the color, it just depends if the wires in it are set up correctly. Okay? That's your physical media. Your data link, like I said, is that area where the physical conforms to logical standards and can be set up to communicate with your computer at that layer, but not a whole lot of information is able to be transferred. Has anybody ever heard of a MAC address? Yeah, a MAC address is a number written on your networking card, but it's also, it's not the same as an IP address. It's an address that's physically attached to that device that allows it to work. Okay? The network layer, though, would be the actual communications over that network card. And when we're talking about today's networks, which are almost exclusively for consumers and for businesses and things like that, TCP, IP, you can kind of see where those letters come from. IP, they're called IP networks because IP lives at the network layer. Okay, remember the network layer is that layer where you're assigning addresses to, and that's why we have the DHCP, the Dynamic Host Configuration Protocol. And then once we've made the connections over the network, once they can talk to each other, then we can use this transport control protocol, which lives at the transport layer, to actually move that information up to where the user can see it using their HTTP protocols. But we're going to be talking a lot about TCP, IP. And we may be referring to those as IP networks. So if I'm talking TCP, IP, and IP stands for Internet Protocol. So we have Transport Control Protocol over Internet Protocol. IP protocol, Internet Protocol, carries the transport protocol. So it's written TCP/IP underneath, or sideways slash. You'll see it all kinds of different ways. DNS, that's another biggie for us. Okay, we're going to be talking a lot about DNS because it's, the computer only knows numbers, right? It knows off and on, and it knows how to put combinations of numbers together. It's a great calculator, can do fantastic calculations. But the problem is that humans can't quickly read a 64,000 character number and compare it to something else quickly and make any sense out of it, whereas a computer has no problem doing that. So we have to have something that sits between our human brain and the computer's number brain, where it only knows binary numbers and it can only count hexagonal and things like that, and it communicates with other computers using what? Numbers. Okay? So we have to have something for us that allows us to make sense, because if we want to go to Sears.com, we don't want to have to put in some 32 numbers in there that if you make one typo, it will never get you to the right place. We want to be able to have another way, so we just use a abbreviation, Sears.com, and is Sears still around? I think it's still around. And DNS is what translates between the name and the numbers, so that we're only presented with the letters that make sense to us. Okay? So the domain name system, also called the domain naming system, is a hierarchical and decentralized naming system. Now what does that mean, is decentralized? That means it doesn't have to be right here in your computer. It can be on another device in your network, or it can be at Google, or it can be at your ISP. It could be sitting, there could be a DNS server in the office, at Wave, or wherever you connect to the internet. But anyway, it connects computers, services, or other resources connected to the internet or private network. It associates various information with domain names assigned to each of the participating entities. And then so if I want to get to Sears.com, I go to my browser up here. And we have these tabs up here. You can open up more tabs than you want to know. But if you click in this box here, up on top here, and you put in Sears.com, and you hit enter, okay, it actually gets you there somehow. Okay, so you can actually go to Sears, and you can buy a little kid that looks just like that with a football. Now notice, we have HTTPS. We don't have HTTP. Why do we have HTTPS? Secure, right. In the club, we actually talk about the Outlaws meeting mostly. We talk about this program here called HTTP Everywhere, that basically tries to make all your connections over the internet using HTTPS instead of HTTP, because it's a much more secure connection. What it means is that if I go to a website that has HTTP and I go pay for something on that website, if someone is sniffing the wire, if somebody actually attaches a wire to my network cable, or it gets into it through my computer or some other way, they can actually, in plain text, they can see all the information I've entered in order to purchase that item, which would be your name, your credit card number, the CVS number, and all the other stuff. So if you ever go to a website, any commercial site, even if it says Sears.com and it's only HTTP, it's either a spoof site and someone took it over and is trying to rip you off, or this company's way behind in technology. And if they were so far behind in technology and they wanted to sell me something, I would go somewhere else. Does that make sense? Okay. So, and then we have the www up here. What does that stand for? World Wide Web, right? And then Sears.com. Now that's a big one. So my website's called adaptivesupport.com. There's probably a shipleycenter.com. What is that thing that's called .com or .net or .org or .ru or whatever? What are those things? Those are domains. Okay? Now those of us who are familiar with Windows domains, where we actually have a bunch of users working together in a large organization in the domain, that's a different domain than this .com domain or the .org domain. And we'll get into that a little more when we actually talk about Windows networking. Right now we're trying to bite off the piece that connects to the internet itself. Anybody have any questions about why this is an HTTPS? Why we have www? Because we're going out to the World Wide Web. And this is actually a name that will be found in what protocol? DNS, exactly. So DNS is like the storehouse. It translates numbers into names and names into numbers and things like that. So people can communicate with computers and computers can communicate back to people. So that was the domain naming system, and now we know there's a domain out there called Sears.com. So that's one domain, and there are lots and lots more. In fact, there are probably millions of domains. So here we see FTP. Is anyone familiar with File Transfer Protocol? HTTP, which is the insecure way of clicking on hyperlinks, and HTTPS. But the main thing is that all these things occur at the application layer. So these are things that you, the user, are going to be using whether you know it or not, okay? These are things that are, I'd say they're behind the scene, except if you look here, HTTPS, you can actually see it right here. So you should be able to relate those two together. And this is an application called a web browser, and this is the application layer, and so these are the different protocols. Now when we look at SMTP, does anybody know what we use that for? We use that for our email. Yeah. All email is sent using the Simple Mail Transport Protocol, a 4-letter acronym, or an FLA. Okay? And then we have this other one up here called POP. What's that used for? That's also used for email. In fact, these two, IMAP, Internet Messaging Access Protocol, and POP are probably the two main email protocols that we use. And what's the difference? POP mail is the older one. That was the one that you used to log into your email and it would load all the mail down to your computer, and all your mail would be on your computer all the time. And if you had two devices, you'd download all the email to both computers, and it was really kind of hard to manage it. So now we're using something called IMAP. And both POP and IMAP are not for sending mail, they're for receiving mail, okay? So the cool thing about IMAP right here is that if I have a phone or a computer or an iPad or whatever, and they all have the same email account, and the protocol I'm using is called IMAP, that means all the mail stays on the server wherever that mail was kept. Okay, it could be at your ISP, could be at Google, it could be somewhere else. It stays there, and your computer only downloads the title of the email and a little bit of information about that mail. And you can click on the mail and it will download everything so you can read it. It also keeps your attachments up there. But the cool thing is that if you're using IMAP mail, and that's really what you get when you have like Microsoft Outlook, or when you have Google Mail and things like that. When you delete it from one device, it deletes it from the server online, which means when you look at it on your other device, it's gone. Okay, the next time, so you only have to manage it from one place. So I know there are some people in this room who still have POP accounts. They might be with OliPen, for example, and all you have to do to get change from POP mail to IMAP mail is just point your account to a different mail server at OliPen, and then you get all those advantages of IMAP mail. But I can guarantee you that over half the people I visit around town here still have POP mail and still have difficulty managing it, and their biggest complaint is, well, I deleted from this computer, but it's still on this other computer. Well, that would go away if they had IMAP mail, wouldn't it? IMAP, okay? So that's the type of protocol. Okay, protocol is what? It's a set of rules. I'm going to ask you that about 30 times. Protocol is a set of rules. we're into our last minute here, Dick. So
Getting pretty close.
just to let you know.
Whatever.
Okay. So transport layer. Here's that TCP. Internet layer. Here's that IP. Okay. So transport layer, internet layer. Remember what these layers are used for? They're used for communicating back and forth between computers. Now, when we look at the link layer, we're looking at things like ARP, OSPF, things that you probably have heard of a little bit. We've all heard of Ethernet, that's that cable, and we all have Wi-Fi at home, or some of us do. Thank you. So we're going to pause for a few minutes right here and take our first break.